So yeah, does anybody have any questions or comments or anything like that? We could do open discussion for half an hour also. That's totally cool.
Hey, Tim, I've been trying to get my camera working all afternoon, but it's just not in the cards. I was going to give a lab tour, but maybe next time.
Oh, Michael, okay. It's not, why is it, it's not even showing your,
It says
Oh.
my video's running too. I don't see any video at all though.
okay, I'm spotlighted. So that will, I'll fix that.
Yeah, as I mentioned, like I was getting the stream set up on my Mac and it decided to do an update like 20 minutes before the stream started, and it was like still in limbo when we were like 5 of, so like I'm like scrambled, and so I had to put my other laptop and get that set up with the stream. So that's running the stream in the other room, but the sound's active, so I just had to close the door so I can't hear my echo.
Give us a tour of Alien Scientist. Just pop up the YouTube. You don't have to play stuff. Just give us a tour of the channel. You know, I've been bugging you for that for, I don't know, like 3 months now, man.
I gotta do something else, like the best of. So I've been let me see what I got here. Oh boy.
I see a tag on your chair too. Do you have a new chair?
So it's this one.
I see we've got Richard
Oh,
Banduric here.
that's actually the tag for my new. I bought this at. I bought a new suit jacket at the.
Oh.
You know how. So let me just. Oh, what happened here?
I got myself some monolayer graphene to test out the Banduric device. If he's at his computer, I'd have some questions about how to electrically contact graphene.
Okay, yeah, I'm at my computer.
Cool. Yeah, so I got me some monolayer graphene. It's about 2 by 1 centimeter, not too big, but how do I actually, what's the best way to contact this stuff that's easy enough to do in a lab? I was thinking either silver epoxy or indium.
Well, okay, so you have to match the impedance on it, right? So if you were to just apply a conductor to it, like a copper pad or something to it, most of the current's going to go through the edge of the pads, and it's going to limit the amount of current you can put into it. Like how many layers is this graphene?
Single layer.
Single layer.
Good stuff. 97% coverage on the surface.
Yeah, okay. And what's its impedance? Did they tell you? Is sheet resistance?
Sheet resistance was something around 100 ohms square, 400 ohms square, something like that. I forget.
Yeah, I think the ones I was getting was 600 ohms. Yeah, so if you want to, what you got to do? Well, the first thing you got to do is there's an acrylic covering on it, right? That you have to take off. You know that, right?
Yeah.
Yeah. So you got to take the ends of it, how much you want to use for a connection, and remove the acrylic from the top of it. So now you have to attach something to it that has the same impedance, right? So something, what I would do is, what I had been doing was taking epoxy and then mixing, some type of conductive material in it. Like you could even use graphene or silver. That's what we tended to use. So then after that, once you make the paste and you've actually taken, a size of a pad on there off. So decide how big a pad you want to put on there, determine how much current you want to run through it, and then apply the epoxy right on it, right? And you got to make the epoxy, you can't use the epoxy directly. You got to put a solvent in there with it, because, you really do need to have it be somewhat viscous so you can just pour it on there. And then after if you could, so you've kind of made kind of like a mold that goes over your pad, and then you just pour your epoxy mixture on it. And then to let it harden, since you're going to have to get rid of the solvent that's on there once you got it applied to the graphene, and you want to I used to use vacuum to remove the solvent, and just do it fairly slow, like it take a couple hours. And you could also use heat, but you can't put that much heat on it. So then once you got this connector put onto it of epoxy that's going to match the impedance to, say, 600 ohms, say, then you would apply your copper pad onto the epoxies, right? So that way, if we were to I guess, visualize it, you have this flat sheet sitting on the table, and you got these two blocks of epoxy that are sitting on top of the graphene, and then you got a copper pad put on top of that. So then you're going to pretty much match the impedance, right? You know, do you see? Do you get?
So do you need like the epoxy itself to have the same ohms per square?
Yeah,
what
yeah,
you
that's
mean?
what you're shooting for. Yeah, because you want to match the impedance there, and then you don't really have to worry about matching the impedance from the copper pad into the epoxy, just because of the fact you're going to be applying it over a large sheet, you know, or pad, right? How big a pad is.
Cool. And then you don't want to use like what was it? You don't want to use soot or just like conductive carbon, because that's potentially that'll make it, will that make a Schottky barrier at the graphene surface, or is it close enough that it will, is silver just better?
Yeah, well, it's close enough. So, I mean, I'm just giving you the general way of doing it. Like we used silver particles. We didn't really use the graphene because the silver was a little bit easier to get the impedance right. Because really, if you wanted to do this in the way that you're really supposed to do it, so you're going to want so if you had a block of epoxy on there, you'd want the resistance of the epoxy to be higher at the end of it that's closer to the sheet part, right? And then you want a lower impedance on the part of the epoxy that's away from the sheet. But that's really a bit too much for someone to try to mix up, right? Because that takes a lot of specialized equipment to make that variable impedance epoxy, right? So,
I can do it with my capabilities, but yeah, that's
yeah, okay. You know, some of the ways to do it is you mix up one batch that has a certain amount of impedance, and then what you do is, instead of using spheres, you use platelets. So if you were to use bismuth or something like that for the platelets, then you would put it into a magnetic field, right? So the magnetic field would tend to align the plates at one end of the epoxy and not at the other, or an electric field. So those are some of the techniques that you can use to vary the impedance of the epoxy, you know, across the pad. Because really, what's going to happen is you're going to have this epoxy attached to the graphene, and it's going to have 600 ohms. But so still, most of the current is probably going to want to run through the 600 ohms that's closest to the center of the sheet, right? Because the part of the pad that's near the edge of the sheet's going to be a little higher, right? But it won't be very much higher, right? You know, because your pad's not going to be that big. So you can usually get away with just having the epoxy be just one sheet, a sheet resistance of a certain value.
cool. And we don't have to worry too much about like Schottky barriers or diode formation at the surface of the graphene.
Yeah, well, I mean, there's going to be a little bit of it there. You don't mind the diode barrier on there because you're really trying to isolate the graphene from the source. So the amount of current you're going to have going through these is going to be in tens to hundreds of milliamps. I've seen some people, they have attached the graphene directly to copper pads, and they've been able to run, you know, an amp or two through it to form a heater. But I've never had good luck trying to attach copper directly to the graphene. Like I said, most of the current likes to flow through the edge of it.
Well, with an amp on that scale, wouldn't you need like a heat sink or something?
Yeah, that's what they were using the graphene for. They had a thick enough sheet of graphene to use it as a heater.
I see. I'm going to have to use a heat sink then, probably.
Well, how much current are you planning on putting through it?
I mean, I was thinking an amp or half an amp, but like with the small cross section that I've got, that's in 400 ohms squared, that's a lot of power. I probably will have to put it under oil or something.
Yeah, I would, you know, I mean, how many sheets did you buy?
I only got one for now, but yeah.
Yeah, that was the big problem with these sheets. You know, they're pretty expensive. I'm thinking that when we were buying them for the DARPA contract, the 10 by 10 sheets, you know, were close to $1,000 a piece.
Yeah, you're not kidding.
Yeah, so you know, if you want to put a lot of current through them, you got to have more than one layer. That's the other thing too, is bonding chemical we dealt with. They were able to get us sheets that had as many as 10 to 20 layers, and in those we could get a significant amount of current through them. But you're kind of limited for the amount of current going through one layer.
Are there other macroscopic materials that have ballistic conduction?
Not well, you know, so now you're starting to get to superconductors, right? I mean, the only thing we found that has they give us those drift velocities that are relatively high, you know, in tens of thousands of meters per second was the CVD. You know, and the next thing you come to is like the aerogels, but they were only giving us 100 meters per second.
Gotcha.
So yeah, so it was pretty in depth for us to do it. You know, when I went to bonding chemical, you know, I ended up, you know, getting, you know, 30 or 40 sheets, and then we had to play around with the first 10 sheets to get this right, right? Because really, it is pretty fragile, those single layer sheets. Have you gone through the handling of them and stuff, and you know, detached them from the substrate and done all that? Okay.
Yeah, I was thinking of how to contact them.
Bonding chemical.
I was just thinking of how to contact them on the substrate. Yeah. So.
Oh, so how did you get the graphene? What was it on?
Oh, it's just on quartz.
Yeah. Okay. So you lift it off. I mean, you can get them on what is plastic? What was it? EP something. I forgot what it is. And that was good enough having it on the plastic already, because then you didn't have to pull it off.
TPU.
Yeah. TPU. Is that what it is?
Yep.
Okay.
Is the quartz too conductive or something?
No, I mean, you can use quartz. It's just fine. We just wanted to use the plastic sheets. That's all. So that was one of the things we didn't really want to do. We didn't want to really transfer it around very much, because it takes a lot of, you know, special handling to do that.
Yeah,
right?
definitely.
Yeah, because you got to be real careful. You don't have the sheet, you know, crinkle up on you. So, I mean, yeah, those are the ways we did it. You know, you could try researching applying it directly to copper pads, but you know, and the other technique that we tried was, so we would have the copper pads on a sheet of acrylic, and then apply the graphene sheets on top of the acrylic and the copper pads. But that's where we had the real problem with all the current going through the edges of the copper pad. Right?
Yeah, it sounds about right.
Yeah, yeah, and I didn't know how to fix that one, because if you put too much current through it, then it would open up.
Mm-hmm.
Yeah. So, yeah, I mean, that's one reason. You know, I kind of, you know, we made a lot of those sheets, but then to tell you there's other interactions going on there that we can't talk about anymore, that the different materials will give you. But you can try using those CVD sheets and see what you get. You know, do you have an electric field meter to measure the electric field over them?
Yep.
Okay, yeah. So and you've got a good way to power them.
Mm-hmm.
Okay, yeah. And so I mean, having the tubes is kind of important. Or unless you can get a hold of really low, you get diodes with really low leakage currents, but
there's up in New England, we got what is it called? MIT flea market. You can get anything there. They sold an Apollo capsule or something. No, it was a Gemini capsule. Yeah.
Okay.
They had an extra Gemini capsule at MIT. They just sold it at a flea market. It was pretty nuts.
Yeah. Okay. Yeah. If you get hold of tubes, I mean, that was one of the other problems, getting hold of the tubes. I mean, I got lucky that they were being sold out of Europe, and we were able to buy a few thousand of them, but I don't see those on the market anymore.
That's too bad.
Yeah. So I don't know, you can always email me, and you know, I can help you try to get the epoxy on there, but that's definitely the direction we went. What were you thinking? Were you thinking of doing it a different way?
No, epoxy and stuff added to it is fairly effective, and I certainly have plenty of silver flake lying around for some reason. Yeah,
Okay, yeah. Yeah, you know.
Yeah, I was just worried that the graphene and silver might form a Schottky barrier, but I guess, yeah, graphene should be metallic in character, so it should be okay.
Yeah, and you know, I mean, when you're dealing with these sheets, you're applying, since you know there's 600 ohms per square, you are applying, you know, 60 to 70 volts on there. So there's any diodes that form, you're just gonna, you know, use the voltage to overcome them, right?
Yeah, it'll be a small loss of current there.
Yeah. So I wouldn't worry about that. No, the big problem you're gonna have now is you got to make a good connection onto the graphene. Using this conductive epoxy. And yeah, and definitely if you've got the facilities to make the epoxy a directional conductive, that helps a lot too. So I mean, the tricks we would use is you would apply the epoxy on there with the platelets, and then have an oscillating electric field applied to it while it hardened. And then when you had the solvents in there, the epoxy would take about 24 hours to harden. So you didn't need to have a large electric field oscillating there. Just a couple 100 volts would get all the platelets to line up over maybe a couple hours.
Yeah, I think I'll just leave it attached to the, oh, you mean for the silver? Okay, yeah. Well,
For the silver platelets in there. If you had silver platelets in the epoxy and you applied the epoxy,
that might make it more consistent. Yeah, I guess. I mean, I've done a lot of this sort of silver ink chemistry stuff. Yeah, there was also for the bismuth. I found something that works pretty well. You just have the bismuth molten, and you can just put that in like glycerol. Just glycerol will do. Erythritol also works, and you just kind of hit that with a like a food mixer, like a cake mixer thing, until it's all emulsified, and then you just splash it in water, and you get a whole bunch of bismuth microspheres. Pretty effective, very consistent size distribution.
Oh yeah, you can buy bismuth microspheres too on platelets. That's what I was just doing. I was just buying them. And the advantage with them is you can use a magnetic field on them to get them to align a little bit.
Interesting.
Yeah, so I mean, give it a try. That's the other thing. I didn't really play around with the conductive inks on them either, because I never thought that they would take enough current. That's another thing you could try. Do you think you can get enough current with conductive inks?
Well, if it's got to be impedance matched, I don't know. It's still going to be limited by the single graphene layer.
Yeah. So that's what I say. Well, good luck on trying to get them connected. And those are the techniques we used. So there might be a lot of different ways to do it. You might want to research on how these guys connected the graphene to a copper pad. But what I think most of them were using is they would use vacuum deposition. They would take I think it's chromium or something that they would deposit on there. But I would think you'd have the same problem doing that too, right? Where all the current would want to go through the edges.
Well, it depends how thin, because at the actual thickness of a sheet of graphene, the effective conductivity of the graphene is very much comparable to metals. So yeah, it can be done that way.
Yeah, and that's what I think these people were doing that got a lot of current through their graphene, is they were using vacuum deposition on there, and they get a nice thin layer on there that they could attach a copper pad to.
That is something I could try.
Yeah.
And
I didn't
for it.
Yeah, and I didn't do that either because I didn't have the equipment.
Well, thank you.
Okay, well, good luck on that.
All right. Yeah, thank you. Yeah, I'll definitely report results here if I do get some good results.
Okay, sounds good then. Yeah, good luck.
Thank you.
Awesome. Okay. Yeah, and again, guys, we can just do open discussion for the next half an hour. Anybody who has anything. Jeremy, if you want to walk us through your website, walk us through some of your top interviews, top shows.
Yeah, you can hear me now. Let me just see if I can't share the screen.
Sweet.
Boom. There, I'm doing it. So, yeah, I've been talking about this mostly lately. I mean, we had that UAP hearing last week in Congress, the first time that UAPs have been brought up in a congressional hearing in quite a long time, I think like 50 years or something. So I've been making a lot of videos talking about that, interviewing different people. I had Jack Sarfati on the other week, had him weigh on it was actually the day of the conference. I sent out an email to a bunch of different people, and Jack popped on, which was awesome because we really hit the ball out of the park on that one with the talk of the Manhattan Project 2.0. I didn't really get into this missing 21 trillion, but that's something I've been getting into like more so the last week or so, is that there's this $21 trillion missing from the Pentagon. I mean, just think of the secret space program that and the funding that we could pay for and what we could buy with that kind of money. It's just absolutely astronomical and absurd to even think about. And we talk about, you know, the Manhattan Project, which only costs like $20 billion in 2020 dollars. So, you know, $20 billion versus, you know, 21 trillion, it's a factor of 3, 10 to the third. It's a significant amount of money, and it's certainly worth looking into. We've been talking to a bunch of experts who've worked, and I'm trying to get some people on who worked in the accounting to track down that money too, so we can sort of collaborate on, you know, well, hey, you're trying to figure out where all this money went, and I'm trying to figure out all this top secret scientific research. Maybe there's some overlap here, and maybe we should look into that. And because certainly a lot of black holes here for coffers for what we could be funding and what I think they are funding in secret. And talk a lot about, you know, the official narrative, things that were pointed out. You know, the Wilson documents were featured in that hearing. They were brought up as a key point and entered into the congressional record even by I think it was Schaefer, the congressman there, and or senator. And I talk about the Wilson documents, but I talk about, you know, more importantly, that there was this Project Blue Book. That was the whole last hearings that they had 50 years ago, was this whole Project Blue Book U.S. Air Force investigation into UFOs that culminated. And in Hynek's notes, there was actually a memo and called the Pinnacle Memorandum, which I talked about and mentioned. This Pinnacle Memorandum shows that there was actually a second Project Blue Book, which was run by the director of Battelle Memorial Institute. It's actually a private corporation. It's tax exempt. They don't pay taxes. It's a military industrial complex, or there's a military industrial complex producer, and they've had contracts. They had the contracts to build the Demon Core for World War II for the Trinity test. I mean, they were the metallurgists that helped, you know, develop the programs at Oak Ridge and the Hanford site to mine and refine all the uranium and plutonium that was used in the nuclear weapons for the Manhattan Project. Their entire corporation was built around secrecy. I think that memo that came out in Hynek's notes showing that there was a second Project Blue Book, which had access to UFO debris and metals, was, you know, is paramount. It's tantamount. It's the zenith of what we can talk about with regards to UAP intelligence. We have access to metals that came from alien, you know, spacecraft. That's bigger than any any video that they could possibly show, showing, you know, UAP. Even if we had high speed, you know, high definition camera showing one of these objects operating, that's nothing compared if we have actual metal and pieces of these things. So that's sort of what I've been focusing on, is the metal and the UFO metals and the pieces and the efforts that have gone on into getting those. You know, these have been recovered by people in the public. The Bob White artifact, I showed that. I compared it to this 1947 CIC document from the Black Vault on a piece of UFO debris that was recovered from a UFO in Denmark by NATO in the 1940s, and went through a series of, you know, chain of custody during the 1950s until it eventually ended up at Battelle, being studied by the top metallurgists and scientists at Battelle, which is supposedly, you know, linked to this whole top secret and a Project Blue Book that, you know, a lot of people aren't talking about in this mainstream. And it should have been, you know, I feel like it had more merit to be entered into the congressional record than the Wilson documents, because this is talking about the last time that the government even discussed this in a congressional hearing, which was during Project Blue Book in the 1960s, when it culminated, I think, in the 1960s, was the last time that they actually had a hearing on this. So I think that Battelle document and this whole idea that there was a second Project Blue Book which had access to the metals and the materials, I think that that is key to this whole thing. The material science is the #1 issue right now with our APEC, the engineering teams attempt to build these materials and reverse engineer these materials so that we can actually do the experiments that we want to do, where we break the Schwinger limit and we bend space-time, or break that polarizable vacuum limit, where space-time becomes nonlinear and we can do strange things to it, like bend it. And we need the material science. And if we have UFO metals, that's the material science. That's the missing key to how to get this to work. And I think that there's a lot more to this with the materials. I think that I've been investigating a lot of that. I want to do a more thorough investigation, and I've reached out to some of the other people who are investigating a lot of this stuff. I want to do more thorough investigation into that Atoms project that was run by TTSA, where they actually went and on this mission to recover pieces. They reached out to everyone who signed up to TTSA, and they said back in 2018, and they said anyone who has metals or artifacts or debris or anything, send them in. We're having this whole project called the Atom Project to go and recover all this stuff. So they went and recovered a whole bunch of UFO metals and debris from the public through this thing called the Atom Project, which you don't hear anything about anymore. They signed an Army CRADA with the Army and handed everything over to the Army a couple of years ago. And I just think it looks like, to me, like a CIA a psychological operation to collect the most valuable, most actionable UFO intelligence that exists out there in the public sphere, which would be the metals, the materials, and then hand that material back over to the military, who, all the conspiracy theorists have accused of being in charge of the cover-up. You know what I mean? So it's kind of this weird situation right now, and have the Wilson documents are being talked about as this UFO crash recovery programs, and it's related to Eric Davis and Area 51, which Eric Davis has got some decent work out there. He's a real interesting guy. Would love to get him on APEC. Would love to interview him here and have him present just even a portion of his work. Some really, really good stuff, especially the latest stuff on squeeze states and how to produce negative energy. I think that that's key to how these materials work and what's actually going on with these UFO materials. But yeah, that's where we're at right now. I've been doing a lot of videos talking about those materials, talking about different things. The Harvard astrophysicist Abby Loeb, who actually, you did a great interview, Tim Ventura, with Abby. It hasn't even got like 1,000 views yet, I don't think, but you asked some really good questions and had a great interview with Abby Loeb. Did you ask him about the, I didn't watch the whole thing. Did you ask him about he said that pieces of Oumuamua fell in the Pacific Ocean, and that he wants to put a team together to go and actually recover.
Yeah. I did actually. He said that was one of his, so he outlined a couple of different projects, and then he outlined the costs that were involved, right? And one of those is, so they're putting basically some kind of a hyperspectral telescope on the roof of Harvard, and once they kind of get some results with that, they want to clone that, right? Which is going to cost a ton more money, but they want to put those as many places as possible. That's one of them. And then, if I remember correctly, he had talked about something about actually going into space that was much more expensive. That was on their list. And then the third item he mentioned was what you talked about, which was an expedition. And I don't remember what the cost was, but it wasn't prohibitive at all. He wanted to pick up those pieces from the ocean.
Absolutely. Why wouldn't you? The materials and the pieces of UFO metals are #1 in terms of actionable intelligence, of things that we can actually use physically to reverse engineer UAP technology, which is, I hope, the ultimate goal of this group, right? So,
well, yeah, I mean, I guess if I could add a bit, my thought would be, materials like that. He mentioned something that was stronger than tungsten, if I remember right. yeah, based on a chemical signature. And oh, you know what? Actually, let me put you on mute for just a moment.
Look at that camera, it just follows them around the room. That's good stuff. All right, yeah. So I've been talking about the Wilson documents. I talked a little bit about this Battelle Pinnacle memorandum. I think Battelle is key to this whole situation because they currently have all the contracts to manage all of our national laboratories in the US domestically, and that gives them incredible control over the science and over the scientific conversation, which, you know, NASA's been trying to join the conversation onto this. And I think we've really hit it off in this community with the right direction for this conversation of where we need to go.
I would say most, not all the national labs, but yeah, they're all used, like controlled by private companies at this point.
Yeah, it's all in the hands of these private contractors, and that's the best way to keep the secrecy so that you can have these congressional hearings where these, you know, Pentagon officials, House Intelligence.
Yeah, you know what? If I could add quickly, I think one thing. Somebody mentioned this in chat. Oh yeah, Brian Kelly mentioned. He said Hal Puthoff's comment, "Any truly deep state increased knowledge is not likely to come out." You know, I think it's also possible. People don't like to believe this, but it's also possible that knowledge could be lost. You know, and like okay, a good example is the Corso book, right? I think it's interesting to look at Corso's book, and that was the one, right, where supposedly they released all these technologies into the private sector to be, you know, to be reverse engineered. If you take a step back and look at it, it's interesting that Corso's book has never really been disproven. And what that says really is that so much knowledge about that has already been lost that they don't even have enough to disprove it. You know, they can't say, oh, this guy was full of it. You know, none of this stuff ever happened. It just kind of, you know, and the reason I mentioned his book is I have a few friends in the military who have cited his book as they thought that the way he described the military was very credible. You know, they weren't sure about the UFO part, but they said, well, the way he described things sounds credible.
Well,
So,
I mean, the same issue happened with Greek fire back when, like,
yeah,
the reason we don't know how to make Greek fire today is they kept it a military secret.
yeah, things get lost, and we don't like to admit that, right? But I mean, you know, this is our government, and our government is kind of incompetent. So,
well, it's not just the government that's the problem. Ever since maybe even FDR, it's been slowly, like they say, beware the undue influence of the military-industrial complex and all that. Well, really, like, you have a whole bunch of quasi-governmental organizations, which are private companies, which kind of just take all of this info for themselves, and they have no checks and balances that say they have to give that information back to the government necessarily. So then it goes into private hands. So then there's just some private company based out of the, like, Panama or something that has a ton of technology that they save for the ultra wealthy, and it's not even in America's hands anymore.
yeah, and you know, and then there are the other projects too, and this again, this would be in the government sector, where well, like the nuclear rocket in the 50s, right? They actually test fired nuclear rockets in the 50s, you know, and it didn't do what they wanted. It didn't get them far enough, and so they shut the program down, and it's basically forgotten at this point, you know, and you know, especially back then.
All the guys that worked on it are sworn to secrecy, and they can't talk about it. And, you know, even on conferences like this, we can't get them out even 20 years later, because some of these NDAs are lifelong, and that's why you have things that get lost to history. Like,
scoot over.
That's
Thank you.
that was
Wait,
part of what I wanted to
I'm
do.
barging in. So, like,
Yes.
everybody loves Stanton Friedman, and he worked on the NERVA project. But they've released all the NERVA project stuff on YouTube recently, and he was the team that basically they purposely blew up the NERVA engine and irradiated Los Angeles. So there's this funny thing with the nuclear rockets and why they don't want people to know about it, but I don't know. It's just a funny tweak in karma. You know, Stanton Friedman was a great guy, but he was working on a project that basically irradiated Los Angeles when they blew it up on purpose.
Yeah. Oh, this was NERVA. There's no Minerva. It's just NERVA.
NERVA, yeah, nuclear
any-
energy rocket something.
Oh,
Yeah.
the RVA, yeah.
There you
Well,
go.
technically, every nuclear test irradiated some area.
Yeah, but NERVA, they blew it up on purpose. They unfortunately, the winds were blowing the wrong direction on Jackass Flats, and everything. It's online. You can find it on YouTube. At least I could years ago.
Jackass
Like it was
Flats. What a
20
name.
Jackass Flats. Yep. So it's some interesting footage to see. I was down at UNM in the business library, and it came out like 2013, 14. And then I got to talk with him at the UFO festivals about it. And
Yeah.
Um,
So these things get lost. I mean, even, what was it? Somebody, I don't remember where I read this, but they said never assume conspiracy when incompetence will suffice. And,
oh, there you go.
and I took that to heart, right? Again, this is the US government. They screw things up. I mean, look at our withdrawal from Afghanistan and the, and the headlines, not to be super critical. The headline, "This is not Saigon," where they've got the same helicopter over the exact same looking building, picking up the exact same looking people on the roof. I'm like, totally different situation. So,
The problem results though, because private corporations, if they're incompetent, don't last very long. And therefore we have a vast array, tens of thousands of private corporations that are competent and dance around the government like it's not even like moving. It's like,
there are like exceptions to that, though. I'm thinking of Microsoft, but
yeah, I mean, once a company gets big enough, yeah, but I mean, if you have something lean and you have a handful of very competent people on the team, you can do a lot of damage, and that's the unfortunate case.
yeah. Anyhow, I didn't mean to distract things too much. You and Jeremy were talking about stuff, and then I think Mark and Aiden are going to jump in with the conference too in a bit.
Yeah, Aiden, what's going on over at the conference?
They're finishing up their dinner speech. It's really neat because they're pulling up the next generation of space developers. So the big thing at the dinner is talking with the kids that won the first place for space habitat
They're
development.
From Ireland, a group of 5 students from a college in Ireland.
High school. They're actually high school students. So it's neat. They've brought in students from like Romania, India, I guess this Ireland group. So it's the International Space Developers Conference. Our bench, our table is the techiest one. We've got all sorts of little things from the lab and that we've been working on, and everybody else is showing off books.
There's one other booth over here right in front of us that's doing data acquisition black boxes.
Oh yeah, my friend James Wolf.
They're also from New Mexico too. It's the kind of thing that you would put on an experiment that has the potential of blowing up, such as a rocket or pod clamp impulse experiment or anything that can blow up. And they're using a Raspberry Pi to store data in a secure memory card kind of thing so that it can survive the blow up and you'll get your data.
Yeah, it's a black box.
And just for folks out there, what's the name of the conference and where can people go and find out?
So it's hosted by the National Space Society, and it's called the International Space Developers Conference. We're in Crystal City / Arlington. Like the Pentagon is about 15 minutes that way.
Wow. Did you say that Travis Taylor was there?
I don't know.
Or was he at the last conference?
Travis Walton. Travis Walton was at the last conference.
No,
I would love to have him speak also at APEC. You guys would have a
Travis
field day
Taylor
with
or
that.
Travis Walton?
Walton.
Travis Walton. I actually had dinner, hibachi dinner with Travis Walton and Nick Pope that night. That was a lot of fun. Travis was actually very interested in what's going on at APEC. He was watching one of the presentations over there at the conference, and he seemed to have a bit of a technical knowledge in science, at least to a bachelor level. And he started sharing details of what happened to him that many people have not heard before, that at least related to the more engineerable side of it. So if we can get him on, I did take the liberty of taking his email, adding it to the email list. So he should have received these emails, and maybe who knows, we'll catch him at some point.
Tom Reed is another experiencer that I've met with at the Roswell UFO Festival, and Tom and Travis are good friends. So if I can work that angle, and Tom has actually invited APEC down to his, he has a conference in Florida. I think it was in like September or thereabouts. So it's feasible, it's attainable to have Travis talk. So like all of my, if I ever talk about ant people and that knowledge of which is a type of alien species out there, sometimes called the mantis or insectoids. Yeah, Linda Moulton Howell's making up all sorts of fun like insectoids right now. But
well, let's try to keep all the speculative stuff out of it.
Right.
The latest things that are happening in the lab right now are pretty much we're moving forward with a more in-depth look at the Podklinov impulse experiment. Todd Desiato is coming down to the lab probably on mid-June. We ordered the acrylic for another take on the Podklinov impulse experiment using the megavolt Marx generator.
Oh, awesome.
It's going to be interesting to have the high-speed camera for that as well set up, and I'm really excited to see what that does. Even if it doesn't work, it's going to be cool.
Yeah, I know. I'm really excited about that. The thing that interests me about superconductors, I mean, spinning superconductors, it's hard to tell, right? Because he did a lot of, and I know Tony is on or Glenn Robertson is on the conference today, but Podklinov had a lot going on there, and it wasn't always documented or described well. But the impulse generator is kind of a brute force thing, which it makes me wonder if maybe that might do it. And superconductors in general, the way that they absorb magnetic fields, and then you get stuff like quantum locking, right? Where they put it on the track and it quantum locks to the track the magnetic field does. Stuff like that. It's almost like you have a macro scale quantum particle. You know what I mean? The way that they behave. And just to me, it's like, if something is going to modify gravity, that seems like one of the things that would do it.
Yeah, quantum tricks. It's about exploiting quantum physics and exploiting quantum mechanics with macro scale objects. I think that's the key.
Another thing that we're about to get, and Jeremy, you're going to go apeshit over this. We're getting a vacuum vapor deposition system for the lab. I already have one picked out. There's a shop here in New Jersey.
I've only been telling you for like 2 years. We need to do.
What can you do with that? Can you do like any chemical or
thin film metamaterials?
Yeah,
thin film
film
metamaterials.
coatings.
Oh, I also have a what's it called? Sputter coater. If you guys need.
Well, okay. The reason I ask is I did an interview. This was a couple of years ago now with the guy who did the world's first room temperature
Sputtering device.
Who has a sputter cutter?
That was me. Yeah,
that was Michael.
I was going to show off my lab today, but my camera is not working as far as I can tell.
Oh, okay, Michael. Is that something that you would add to the vapor deposition machine, or is that a separate machine?
I mean, they can do slightly different things. I mean, I do have tungsten vapor deposition boats, and if I need to vapor deposit stuff, I just pull a vacuum on a vacuum vessel and heat up the thing resistively. And I mean, that's easy enough to just do. Sputter coating does some things that you just can't do with vapor deposition. Like if you're trying to, you can't really vapor deposit tungsten, for example, with practical systems. You can definitely do anything refractory with this though. It's butter coating.
Yeah, it's
Okay.
also how they make the pyrolytic graphite or the pyrolytic carbon is through sputtering.
Graphene monolayers, etc.
We're thinking of doing probably aluminum, bismuth,
Magnesium.
magnesium. Yes, those lower. But I also wanted to see if I can get iron, and I don't think the coil gets hot enough for iron. So
I've been telling you guys, cold spray is probably the best way to get, at least mechanically speaking, cold spray is the best you can do there. I heard that maybe the zinc in the magnesium was due to a zincate surface coating, which suggests the thing's man-made.
What do you think
And-
about
'cause
building
the
this in
zincate
space?
surface coating is what you would use to coat magnesium with other conductive materials in an electrochemical bath. So basically, it would be electroplated if that were true.
What, sorry, for what piece of metal?
For the bismuth magnesium composite.
Oh, I see. Okay. Yeah. The arts parts, you mean, right?
Yes, which would make sense if there's a zinc layer in between, because that would just further stabilize any quasi-particles that are in that layered material, if there was a slight insulating layer between the magnesium and the bismuth.
We talked, the aqueous method is also, there was a company that was developing like long-lasting pipes, and they were using an aqueous method.
Modumetal.
Modumetal, thank you, that company. I tried to contact them or get in touch with them back at the end of my UNM time. They weren't very receptive to me, I guess, at that
They're
point.
just
But
doing stuff at scale at this point.
yeah,
But I mean, if you guys want to recreate roughly the technology, what you want to do is, instead of using an aqueous bath, you need to use deep eutectic solvents, which are
it's a fancy word. I hadn't heard
What is that? Spell that out. Deputectic.
I can put it in the comments.
What about doing it in a vacuum? Like we could build this in space.
That's what the ISDC is all about. Like with the kids, I've been saying, well, we need like an orbital manufacturing facility. So can you I was showing them, there's the inductive heater where they have the aluminum blob in it. And
Well, if I could jump in just real quick, I just want to plant kind of a seed of an idea. So I did an interview with a guy who discovered the world's first room temperature superconductor, right? And the complaint with the media, just because they always have to have something, was he put this thing under like 10 million PSI in a diamond anvil to make it work. So one of the things I asked him in the interview was, I was like, okay, why did you do that? And he said, well, it was because it was the hydrogen atoms in this lattice that made the thing room temperature superconductive. And he said, to get those hydrogen atoms close enough together, we had to put it under this incredible pressure.
Yeah.
And so then my thought was, what if you tried some kind of a vapor depth system to lay those down that close together? Then you wouldn't necessarily have to press them. And he said that was something they were going to try. So if you guys have vapor depth, that might be something to look at also, is, trying to vapor depth, stuff like that. Supposedly with room temperature superconductivity, the thing that's moving that whole area forward is, about 10 years ago, they got really excited about hydrogen atoms. They'd ruled those out years ago. I don't know why.
Yeah.
They got excited about them again.
Because at my former friend Ed Fouché, who's a former Area 51 employee, he talked about metamaterials and quasicrystals back in 1998, before anyone was talking about this stuff. And one of the things he used to always harp on was this hydrogen crystals. And he said that there was tons of research. It was the most hush-hush thing going on out there about, at the time, about hydrogen crystals.
Which reminds me, Jeremy, look at non-hydridorenate compounds again.
whoa, slow down one more.
There's another big word, Michael.
Yeah, he just drops them like that. Hydrinorenate.
Eutectics, I've heard of. It's like EUT.
I suspect ammonium monohydridorenate will have enough hydrogen to other atom ratio, that if you compress it to mild pressures, it might do some interesting things.
Michael, I would say I'm reasonably smart, and I'm very well read. I've never seen that word. I've never even seen a word like that before.
It's quite remarkable, actually. They used sodium borohydride to react not rhenium salts, and then they assumed that that compound was the rhenium +1 ion, but it turns out that it's actually a complex with 9 hydrogens and 1 rhenium atom. It's fascinating, and it's stable at room temperature and room.
What does it do?
I don't know yet. I mean, we have to see what it does under compression.
Yeah, but I mean, compression, I mean, nothing that maybe in your power source, like, give me something that can make muons or tauons. Like, I want something that can make tauons. No, not antimatter.
No, I mean, the other
just
thing
want-
this could be useful for is lattice confinement fusion, but that's a whole other ball game.
Have you looked into this muon? Oh, it's muon assisted fusion is the
You know,
next stage.
guys,
That's
and-
Sorry.
I don't want to take it too far off track, but you remember Michael McDonough presented on the plasma volt, right? And that was an old contact of mine. So that avalanche energy that's been making the rounds, avalanche.energy.com, they just had a news story about something like a 5 kilowatt excess fusion generator. And when I looked at their process for it, it is very similar to Michael McDonough's plasma volt. So, so I do think that's interesting. For me, it lended credibility, I guess, to the project he was working on. That might be something for you guys to experiment with also, that might be an experiment worth doing. Fusion in a bottle, and it was not too difficult to make.
Well, I gotta get
Well,
back in touch with some of my contacts up at MIT, like Mitchell Schwartz at Jet Fusion, Jet Energy Technologies, and Peter Hagelstein, because I'd like to see what they're up to with their cold fusion research, because it relates, very closely to a lot of this.
Well, just reach out and work through the alumni association, or just
Yeah, I'll just email them. We'll see.
okay.
Yeah.
Jeremy, what would you like seen made with the vacuum vapor deposition machine?
Well, let's, if we could make that material, that Linda Moulton Howe material, that arts parts, where it's like the 3 micron bismuth layer with the
100 micron magnesium.
Yeah, if we could just get magnesium and bismuth and just vapor deposit that in layers of those thicknesses to match that material, that would be an epic start.
Yeah.
And maybe try one with zinc too, as Michael was talking about. A little
Yeah.
bit of, the sky is the limit though. Could you do food with it? I'm just thinking,
No.
what if you
gold
did the
food.
world's thinnest crust pizza?
Thinnest phyllo dough.
I'm just saying, you don't really need to discover gravity. You would be so rich, right? Thin crust is
It's
in.
atomically
Oh,
thin phyllo dough.
No, we need a laser cutter. We had at the Fuse Makerspace one time. It was late night shenanigans, and we got a slice of pizza pie and flipped it over, a slice of pizza, and then we laser engraved pie on the backside of it. So it was
You
pretty
had
funny.
flaky baklava, but have you had atomically thin baklava?
No,
That sounds good.
Ooh, vapor
Loads of
deposit baklava.
That sounds really good, man. You
Jeremy-
want to clean the chamber really well, right? You want to clean that
You know what's
chamber.
actually really good? Cryogenic potato chips. You stick potato chips in liquid nitrogen, they are amazing.
Oh boy.
Yeah.
It's
Crunch.
that water.
Aside-
But, I've got.
Jeremy, have you had some?
Hold on. let
We
me-
had it at the lab once. I think Jeremy got a couple.
Well, what you need for the
Okay,
liquid
so-
nitrogen is the liquid nitrogen beer cozy, right? That's what you need
You
for
know
your
what? I had a drink with some liquid nitrogen in it because we had liquid nitrogen in a demonstration one time at a college thing at school, and I put some
Dry ice.
in my drink, and I used it to cool my drink. It just just evaporates off the top as nitrogen, but
Could I,
Huh.
aside from really thin baklava, could I ask for just a sentence or two about what some of these materials like the magnesium and bismuth might be used for?
for it.
How put off?
it's waveguides. So it's you want to get the most bang for your buck with the
Ooh.
littlest amount. You want to pump
I need
an,
to talk though.
you want to pump a ton of energy in a small amount of space. So what you're looking at is hysteresis of materials, I think, is the key to it. And it's
Say the
that
word again, please.
hysteresis.
Okay.
Yeah, Elliot, and if you want, bismuth is in our community, if we have a community, bismuth is one of those magic materials. It's the same chemical group as element 115. It's like one step up on the periodic table. But what's interesting about that is bismuth in the mythology of like gravity modification and energy and all that kind of stuff, in this cultural mythology, bismuth dates all the way back. It's highly, if I remember right, it's highly diamagnetic, highly paramagnetic, something like that. But
Diamagnetic.
yeah, and
In fact, element 115 is right below bismuth on the periodic table.
the other thing is, like,
Same
okay,
family.
for instance, it just shows up in the strangest places, right? Like I got really into the Philadelphia experiment years ago, and I was reading about that, and there was this whole thing about, well, they designed it a certain way, it didn't work a certain way, and I found some folks who said, well, why would that be? What would the unknown factor be? It turns out on the Eldritch, this is just one example among many. So when they ran the welds for the Eldritch during wartime, they had a problem with lead. They had lead shortages, and then they had problems with the heating for it. So they were running bismuth in the welds. So the Eldritch was shot through with bismuth. All the hull plates were welded together with bismuth mixed with lead, if I remember right. So
But that's
That's
not
amazing.
very, yeah.
Another interesting thing about bismuth is that although it is very cheap, you're talking dollars for a pound, it's actually just a little bit more common than gold. It's not a very common element. It's kind of rare. And the only known commercial use for it is Pepto-Bismol, which is stomach antacid pills. So you can get bismuth for pretty cheap, and it's rare.
they use it for non-toxic birdshot.
Yeah, there's also some videos where you can actually take Pepto-Bismol and extract the bismuth from it. They show you how to do it. in the
Well,
lab.
Red Nile
Oh,
or
I just
If-
realized
if-
something.
If you wanted large amounts of it, you would just buy it as birdshot, buy it as non-toxic birdshot. They use it because it's close to the same weight as lead, and it's close to the same.
You
know.
could buy it by the ton. There's some companies online that sell it. They have quite a bit of it in stock.
Mark, I just
And
realized.
somehow layers of bismuth and magnesium create a material that can contain a lot of energy is all.
no,
whole
Hal Puthoff talks about it in that Weinstein interview that came through a couple months
Yep.
ago, and that basically it's a waveguide amplifier, or
Yeah. Start with his paper on
properties.
Hal Puthoff has a paper called Polarizable Vacuum Approach to General Relativity, which is kind of the theoretical basis for a lot of the research that is being done right now into these metamaterials and these effects. So that hysteresis curve, like I mentioned before, and it's the sharp points on the end of it, and you want that to be as sharp as possible so that you can create these incredibly high energy densities at that point, which could theoretically break the Schwinger limit of space-time. And if you can break that Schwinger limit, that 10 to the 30th joules per cubic meter, with that kind of energy density, you can actually break down the quantum vacuum and separate, space and time.
I'd also like to point out that bismuth telluride sulfide is the first practical topological insulator.
there we go. There's a fancy word.
It's
And
a,
that was in the presentation that won the conference over here. They were going to use that as a radiation shield.
Yeah, these kids had some interesting ideas. I haven't
I mean,
for
I know some
radiation
Russian nuclear
shielding.
reactors used bismuth tin as a radiation shielded, but also as a fluid to pump through the system too.
It's an
Yeah.
alloy of bismuth and tellurium.
Bismuth telluride sulfide.
I
Two-
think I think NASA was actually looking at that. They had some other ideas too. If you're talking about manned space flight, Dennis Bushnell was talking about loading the water outside of not outside, but loading the water in the shell of the craft, right? Because your occupants have to have water, and so you use the water as a radiation insulator.
That's a smart idea.
Yeah, that's in like Mars, going to Mars, they would have, if there's a proton storm or like a CME coming in along the flight path of the vehicle, they would get a warning from Earth, or there's websites that track the outgoing CME bursts. But anyway, they would go into a little area inside of the ship that has a water pig or a water sheath around it. So they would get some protection from the high energy particles coming in. Yeah.
Best
8 minutes.
radiation shielding has some dense atoms and some very light atoms. So that's why you typically see like tungsten or tantalum or bismuth mixed with plastics, because then you have the light hydrogen and carbon, and you have the heavy bismuth or tungsten or tantalum. And
Yes.
both of those block different types of radiation, but together that's how you optimize.
On ISS, they in the astronauts compartments, they have it's like that normal plastic, like the clear plastic that you'd use on your windows, but they dope it with extra hydrogen.
Now,
So it's like hydrogen rich, I don't know, PTEF or whatever it is, or PBT, polybutylene.
my understanding is that if you go out near Jupiter, that whole area is super hot. So
Well, Jupiter is it's a protostar. Give it
Yeah.
another billion years or something after the sun goes supernova, 5 billion years, and it probably will be cut loose and catch a bunch of the outgoing plasma and start turning into a star again. So, or not again, but evolving into it. Yeah, that's in circles. The liquid metallic hydrogen stuff, which ties into the Ed Fouché. When we were talking about that, I know there was the original scientist was out of Japan. I'm grasping at forgotten memories, knowledge, but yeah, the Japanese were proposing that the sun is, it's made of liquid hydrogen, or it's not a gaseous ball. It's actually there's a solid surface to the sun if you could somehow withstand going through the corona and standing on an active nuclear moment. But so that would tie into some of the quasi crystal stuff. There may be something there. I don't know. Just peering in the dark, trying to figure out if there's a connection to these quasi crystals. There's a thing I've been trying to spit out. I did order a book on metamaterials. So when we get the CBD machine in, Jeremy, we'll have some textbooks we can go through and look for different metamaterials that are out there, or at least in this textbook. So yeah, I don't know what else is there.
More materials we could talk about. There's ammonia mercury mixtures. Those form semiconducting liquids, which when you apply pressure might become superconducting. That's worth studying. Yeah.
Okay. Boron, from my early on in my studying ufology, boron was sought after. Who's that guy? The U House was talking about it, that the aliens were coming down to Area 51 and they wanted just straight boron because it was a good beta blocker, and they were using it as a radiation shield on the inside of the vehicle. So there's playing around with
Isn't it a good neutron absorber?
beta particle.
Well, anything conductive will be a decent beta particle.
Okay. Maybe it was a neutral counter. It was off of the Desert Rat website from the 90s.
Boron is pretty optimal for neutrons.
Okay. It was the
And tin is
neutrons.
okay, I've heard.
Oh, tin?
Just because it can absorb a lot of them before it turns into anything else. It transmutes. It's got a lot of stable isotopes. I don't know if the cross section is particularly large though. I think the other one that was good was gadolinium. Yeah, something like gadolinium, and then hafnium is all right.
Huh.
If I remember correctly, there was another material in the arts parts sample other tan bismuth and magnesium.
I think the gadolinium was used. Didn't they use that as a wetting agent also in reactors, if I remember right?
Gadolinium?
Yeah, maybe I'm thinking of something else. One of those was a wetting agent in reactors.
No idea.
Time to go to UNM and see what nuclear engineering textbooks are in the used books section. There's gonna be some good stuff there. So there's only 5 universities in the United States that have nuclear engineering programs. One of
You-
them's Reed College, another one's UNM. And I don't know the other 3.
Yeah, if you
So-
guys are able to vapor depth the bismuth magnesium, especially if you could clone the Earth's parts, maybe you just start selling that to investigators, UFO buffs. Think about it. People probably pay a few $100 for it, you know?
Yeah, but I mean, it's what, 3 microns and 100 microns. Like it would be easier to get a magnesium film. We do a layer on one side and on the other side, and somehow get it just warm enough, or like a friction stir melt, and do that a couple times after we've put bismuth on one side. But we're gonna have to be working in a controlled environment so we don't get dust and atmospheric contamination.
I just found on eBay under everything else, then weird stuff, and then totally bizarre stuff. Somebody posted a UFO metal fragment in a jar with UFO blueprints.
And they're trying.
You could buy UFO fragments on eBay.
Yeah, right. Maybe. No, we should start a APEC store and
And don't forget about the thin crust pizza. I'm telling you,
Yep.
that's an idea. There's
Yeah, atomically thin crust. We'll sell
Yeah.
We'll sell it to Pizza Hut. And we'll, like get Papagino's and Pizza Hut to bid in a bidding war on.
oh, is it Papa John's? Yeah, Domino's. I think Domino's would be the better sponsor. Start pulling in some corporate. Well, if we do that, we become corporate whores. So
Oh, it's bismuth, magnesium, zinc. Zinc is the third metal. We have
Zinc.
both of them in stock, so.
Yeah, that just makes it more electroplatable. So that's my guess on what it's about. I think it was made by electroplating, especially the surface finish looks electroplated to me. So I was going to mention, Mark, you should get some Pepto-Bismol, because if you react it with hydrochloric acid, you produce salicylic acid, which happens to be an almost ideal corrosion inhibitor for magnesium. So you're going to need salicylic acid when electroplating your bismuth magnesium layers. So you probably actually you could put Pepto-Bismol in there.
Why can't we vapor deposit the magnesium and bismuth?
I'm just thinking that the composite that we saw from Art's parts looks, for all intents and purposes, electroplated.
I mean, we really wanted, there's a couple other things we wanted to do with the vapor deposition, including thin film aluminum and maybe thin film iron on top of it, really thin film. And we can layer stuff and add oxide layers to that as well. Also, Todd was excited about making split ring resonators using a stencil. So the stencil sits down, and that's the part that doesn't get deposited on the substrate below. And you pull the stencil off, and you got yourself a thin film split ring resonator for a negative refractive index, and we could tune that to a specific frequency and do that setup as well.
Could build some really small C-ring resonator arrays. Yeah.
Frankly, I think that a lot of the stuff, at least that we think will operate at terahertz, until we have something to measure and produce terahertz, is a little bit tricky to look at.
So
I mean, there's ways to
that's
do
good.
it. There's ways to do it. I could give you some.
Oh, where's Jeremiah? Well, my idea from listening from the group talk, the group think, is based off of Jeremiah's experiments with spherical capacitors. You know, in this case, like the shell, the aeroshell, the hull of the flying saucer is quasi-spherical. And if it's made with that the magnesium bismuth stuff, like the inside, the resonator, whatever is generating the pulse, may be at a much lower frequency, but that amplification, the waveguide amplification, combined with the fact that it's nested shells or like a spherical, quasi-spherical capacitor, gets you up into the terahertz range on the outside of the vehicle, but the emitter on the inside of the vehicle is much lower at the by a factor of 30, if what
You'd
Hal
have to-
Puthoff said is correct.
You'd have to explain what the coupling term is there, maybe, but I mean, you can just get a zinc cadmium, what was it? Not what was it? Zinc selenide? No. Okay, guys, zinc sulfide.
That's what I need out of that.
Zinc sulfide selenide with cadmium doping, and that emits terahertz as a laser. Or you could work with a near infrared laser and feed that into an optical parametric oscillator, just a BBO crystal, and that's completely, the thing is, that's completely tunable, so you can hit anything in the terahertz band.
But
with-
you're thinking with calculus and boxes, and you're shooting a beam. I'm trying to think of like a way of getting a sphere, right? You know, with the propulsion field around the vehicle spins. So if we can use that knowledge that Jeremiah has passed on with using spherical capacitors to get more voltage on the outside, and then one of those capacitive shells is this magnesium bismuth laminate, multi-layer laminate that seems to amplify. Or
But you're talking about like megahertz versus terahertz. There's a
right, and then it's a material effect in the hull that's giving you the bouncing it up to the terahertz regime.
What would that effect be?
That's what, listen to the Hal Puthoff, Eric Weinstein discussion when he goes into talking about the magnesium bismuth laminate and how it seems to amplify, or it's a 30 times, a waveguide amplifier. It makes,
Oh, yeah, no, it reduces. So it's a metamaterial, which it's a plasmonic metamaterial in some sense, but that doesn't mean you still need a terahertz input. You can't just take you can't just take a megahertz signal and expect that to go up to terahertz. It's still
You can't convert it through material.
The terahertz waves in such a waveguide would be 30 times smaller, but they're still waving at a terahertz in terms of frequency. It's just that they're smaller spatially because the refractive index of that medium is much higher. So if frequency is the same, the waves in space are distributed 30 times closer together, if that makes sense.
What's the spectral band for terahertz? Where's that fit in spectral band?
It's like infrared to
Sub-infrared, between microwave and infrared.
yeah.
So yeah, so you went deep IR.
Yeah,
and that's a tough band. I remember reading about that because they're looking at that for imaging and they have problems with it. That's a tough
there you
band.
go. Sorry, Jeremy just put up an article that's perfect for this. Yeah, it's what's this? Yeah, lithium niobate.
Lithium niobate chalcogenide, and it's hybrid waveguides that do acoustic optic modulation, and we'll do like frequency up conversion. So we had mentioned using some types of materials to use frequency up conversion to reach that terahertz gap. Basically, is that we could use materials to build a modulation system, because that was the issue with the arts parts originally, that they had needed to give those things to the U.S. Army under that CRADA agreement because they didn't have the terahertz capabilities to do the experiments that they wanted to do. And so I wanted to discuss, like, is there a way that we could build a material like using these thin film up conversion?
You don't need you just need you need an optical block of beta BBO, like something beta barium borate, something like that. Or you can use a lithium niobate crystal too, but you don't need a thin film. You just need a crystal. You just need a
Yeah.
cube of one of these materials and an optical table and some reflectors and some components that operate in the far infrared or the terahertz spectrum, mostly zinc sulfide, zinc selenide, that sort of thing.
Look on YouTube. It's Delmar, DELMAR Photonics, I believe, or Delmar Optics. But they're coming up. They're very, they get like 2 or 3 likes whenever they put something, but they're messing around with the right type of optics to get up into the terahertz range.
There we go. The parametric oscillator for phonons. That's another good one.
Yeah, these are some good articles that I found recently. Actually, Jack Sarfati posted this one, which I thought was super interesting because it's like, all right, well, he's finally been looking into some of the material science stuff that we've been sending him.
Jeremy, can you find Delmar Optics or Delmar Photonics? DELMAR. It's on YouTube. They show their.
Was it DEL?
Sulfide, not sulfate.
Delmar Photonics, I think. There we go. These guys are the buyer's guide. Nope. Go back one. Well, maybe. It was the first link. There you go. And they have a YouTube channel where they'll show the little crystals that they're making.
Nice. So these guys make I know nonlinear optical crystals, like to do the experiments in the kind of stuff that we talk about on this channel we want to do, that they're very export protected technologies.
Yeah.
And
AI tar.
yeah, that you
Higher
can't
resolution on your radar is what it translates into, so you can see smaller things.
Titanium sapphire, that's what they use for chirped pulse amplification. It's fun stuff.
yeah.
Need some
They
water.
sell it here, but it's hard to produce a lot of the stuff. It takes a lot of proprietary methodology and equipment and stuff to make a lot of these nonlinear optical crystals that are commercially available on the markets. So it would be great if we could develop these types of capabilities and sell these types of products, because
No, we can't do that in-house, most likely. It's because you need single crystals. So you typically need to pull a single crystal, similar to how they make silicon crystals, out of a molten bath of the material, which is that's extremely difficult. So because it's not just you don't just melt the thing together. Otherwise, I could do that right here with my stick welder. You have to make sure
I'm wondering what's capable, what's what kind of processing we need to because we need to basically think like Leslie Graves in 1943 and 42, or 38 rather, like the 1930s. Like, how do we set up the manufacturing capabilities here domestically to even build the next generation of these technologies? Like, do we have?
There's one thing to get a prototype working. We could use materials in liquid. So there's certain materials that will produce nonlinear optical effects when they're simply dissolved in water, and those might be sufficient. They'll remain isotropic because they're dissolved.
Yeah.
That might be the best bet. And I mean, you never know. If you go to, if you should join when the next what do you call it? MIT flea market happens. I'm sure they'll have some optical crystals around.
Yeah, we're gonna go to that. The next one for sure is gonna happen. And what do you think about space manufacturing? Like,
yeah, you can make crystals more easily there, but it doesn't make what we're doing any easier. I mean, getting to space kind of negates the easier crystal manufacturing.
On another topic, Jeremy, can you Google the Tau Herculid meteor shower? There's this comet that normally produced a very weak meteor shower at the end of May. So this coming Monday night. But in 1995, it broke apart and we're going to be going right through the debris from that breakup. So there's a chance that we'll have a meteor storm with thousands of meteors per hour on Monday night. So
Oh, that'll be fun.
that'll be fun. Yeah, there's a chance of some big ones too.
So again, like when we talk about improving resolution, there's a lot of interesting research being done right now.
Quantum metrology is some of the best stuff that we've gotten recently out of quantum mechanics.
Yeah, because this is like they set up those. I remember that they had to measure the distance to the moon, and they set up a mirror and a laser, right? And we should set up a big camping trip this summer where we all like people can go like on a camping trip with all of us and like.
Yeah, that'd be great. Next year's second year anniversary. Well, except for we got to go south to Florida. And then we can hang out at Tom Reed's place in Florida or something.
We gotta like get. I mean, we have basically like Jack Sarfati has said like he's linked up with people who promise him unlimited funding if we can just come up with a prototype and something to show. And we have probably enough of this community together now and enough of the knowledge to build this, to work on a reasonable prototype, or at least a lab that can, build the stuff we need to build the prototype.
That sort of like unlimited funding comes with a bunch of asterisks, though. You got to know.
Yeah.
If you can do it another way, it's preferable.
Yeah,
but yeah, I mean, it's a lot of money on the table, sure.
Not worried about the money on the
Buy it.
table so much as I'm worried about, us getting to the point where we can figure this stuff out and get it out to the public before it can get in the wrong hands or just go dark and disappear into a black hole like so much of everything else has done.
It'd be too late. We don't know that at the moment. I mean, there's already things flying in the sky. Who knows whose those are?
Yeah, it's hard to say. And
yeah, sorry, I just came back. It's hard to know whose those are, and we probably shouldn't try and define things either. I mean, and I mean as a not as us, but I mean as a species, right? Like I tend to think that UAP are von Neumann probes. That's kind of what my gut tells me. But one of the things she said this to me months ago, Julia Mossbridge, I was talking to her about UAP, and somebody had suggested, well, maybe these are time travelers, and I mentioned that to her, and she said to me, time and space aren't what you think. Probably try not to put it in those terms. And, and I sat back and I thought about it. I'm like, okay, even if they're not traveling through time in a reverse time way, when you start talking about the scales that are involved, it does make sense, so. But I think that then there's this other thing too of, this is me personally. I don't believe in any kind of biological aliens. I think that these things are machine probes, but I think that once a machine reaches a certain level of advancement, it's probably not helpful to think of it in terms of machine or biological,
The most advanced nanotechnology we'll ever need is biology.
Yeah, I mean, nanotubules and some of these other things are just way beyond what we could engineer ourselves.
Microtubules, but
yeah, I have an interview coming up with Jay Storrs Hall. We did one on again, that's on my channel. We did one on nanotech utility fog, which I've been in love with since I read about it in 2000. That is just the coolest idea ever. But
it's basically just yeast. If you think about how yeast has become so programmable recently, you can just make whatever drug with it. Like that's basically just yeast already.
Don't ruin it for me, man. Don't ruin it for me. Don't ruin my dream. But
mushrooms are just nanomachines that turn wood into food.
But he was talking about he just wrote a new book called Where Is My Flying Car? And I haven't read it yet. I just downloaded the Kindle, and that he's talking about nanotech nuclear. And so I want to do an interview with him on that. So
Tim, in like direct contradiction, here in Taos, or not here in Taos, but there in Taos a couple years ago, there's a massive spaceship, or a couple hunters walked up onto something that looked like a circus tent out in the middle of the forest, and they met two crew member outside of it. They said they were really tall, but had some sort of strange, like they were in black suits, and then they couldn't see the face because they had like a glowing screen on their face. So and they got a good interview on the TV and local news, and they were, very certain that what they saw was, two sentient beings outside of a spaceship that looked like a flying circus tent that had landed.
Yeah.
So,
I mean, I don't know. It's stuff like that.
come here, say hi to every. No, we're on our meeting's going. Say hey.
Tim, if you're interested in von Neumann machines, Tim, you should check out Carbonado diamonds. They impacted the Earth probably. People think it's meteoric impact about 2 billion years ago. Interestingly,
Our group.
that impact happened right before the Great Oxygenation event. So it could be that the remaining Carbonado diamonds are pieces of some spaceship hull,
Figure out some way to
or some von Neumann probe hull that was meant to terraform the planet using photosynthetic life. Because photosynthetic life was introduced
terahertz.
at that point in Earth's history. So either it's temperature got cool enough that it could photosynthesize, or it was deposited there by that von Neumann probe.
Yeah, so this is like
Interesting.
It's interesting how Carbonado diamonds are not like natural to the periodic record and geology of those areas, and that
the
they're
moderator.
they only appear in two places, right? Bolivia and Central African Republic, right?
I know.
That I'm aware of, and
If we keep
Not Bolivia, Brazil.
Brazil. Right, but they're unnatural to the local geology, right? That they're
And
just
they don't have the same ratio of isotopes as Earth, so they're definitely from space at some point.
right. There's a whole extraterrestrial hypothesis
Yeah.
on them. If you look at
Carbonado
Carbonado,
down here. You can see his face on here. As
I thought they were harder than regular diamonds, right? Or no?
Because of the polycrystalline structure,
Romania.
there's always some component of the material which is the maximum hardness that it can be in that direction. So you will get the highest hardness possible for diamond and testing.
Yeah, but it would be directional, so you could basically engineer this material on the skin of your craft so that
I mean, the samples that we have don't appear to be optimized in any particular direction, but the fact polycrystalline. And what was really interesting was, Jeremy posted this to his channel a year or two ago. We found what appeared to be acicular grains of titanium inside these. And the thing about titanium is it's really good for sequestering nitrogen, and nitrogen prevents the sintering of diamonds. So that seems like a technosignature potentially. At least from an engineering standpoint, it would make sense why there's titanium there. And there have been other reports of pure metal acicular grains of vanadium, other materials. But the prevailing hypothesis is they were from a supernova, and if that was true, you would see a bunch of alloys. You wouldn't see grains of pure metals that are separate. So it's very interesting for a number of reasons. Can Tim hear us?
Yeah.
Oh, okay.
Yeah. No, I'm listening. We're still recording too.
Oh,
And this
cool.
is really good stuff. So one of the reasons that we're having wonderful conversation again is because we very politely asked some of the disruptive guests not to join us anymore. So just so you know, we had a few disruptive guests. In fact, we had one earlier today that we asked not to join us. So
well, I mean,
yeah.
it's good that we've been very respectful to the more inclusive we can be, despite that, the better. in the long term in terms of like building credibility with the average person. If you have
Yeah, I want to be inclusive, but the thing is, I don't want.
You don't want to be too exclusive either, especially with the modern political paradigm. If you're just exclusive, then people will stop trusting you. So
Yeah, that's
good. It's good that you've worked hard to try and include everyone.
Yeah,
the people
and you
who-
know, I think we've really bent over backwards, right? I think all of us have. We've had, you know,
Yeah,
we've
we
all
have.
had eye
trying to-
rolling moments. So
Yeah.
the if I may, like that's been the nice thing at this conference over since the UAP congressional hearing thing. Like people, the old men in the group, they're like, there's some from the international space elevator community that 2012, I'm like, oh, I saw optical cloaking and there's glowing dots over the nuclear labs, and they're like, yeah, whatever, Aiden, like that's nice, sit down, we're here. This time they're like, oh, okay, like what are you working, oh, that's neat. And you guys, like, our table here has got the most tech on it, and it's the winds of change are blowing, and people are coming up and going, oh, it helps that, with my iPhone that I have footage of the little glowing dots in the skies over the nuclear weapons lab. But it's much more people are like, oh, what do you know? Okay. And I've gotten a couple interesting UFO stories. And so the whole tone on the conversation has definitely shifted. It definitely shifted. That's,
Well, yeah, we got to keep it that way, but also still aim to be as inclusive as we can be, just because, I mean, in the modern era, that's the whole reason why people don't trust the science anymore, with like Fauci telling people, oh, masks don't work. Come on, trust people to be like, you just tell people like, okay, we have a shortage.
yeah, I would
Percentage.
agree. I would agree with that. And I think that we've all tried really hard to be inclusive. I think some of the challenges have been, you always have folks who are, they don't want to participate. You know what I mean? There's a difference between participating and, we've had some attendees who just didn't understand scientific fundamentals and weren't able to participate. And then we've had a couple others who want to redirect things under their own conspiracy theories, and we've all had our share of conspiracy
That's
theories here,
happen.
but
That's going to happen because there's a lot of forces that are trying to co-opt and subvert what we're trying to do here right now and lead us in the wrong direction. Because
well, just stay focused on making, we got to build stuff, make,
Very true.
make,
Right.
get your hands
That's why the
dirty.
science is leading the way. I think that doing the scientific method is important, and it's important to include the best possible people that are going to have the most to contribute in terms of actionable intelligence, because that's what we're after at the end of the day. We're not after the data, we're not after the info.
Yeah, there's a lot of political astroturfing these days, and you got to be careful about that. But also, there's a lot of real people who just don't know what they don't know, and feelings get hurt, and that's the unfortunate thing. You got to just do the best you can.
yeah, there's no perfect answer, but I think that we've done pretty well overall, and
We
we've
give everyone
broken
a chance. You give everyone a chance, and if they prove that they have nothing valuable to contribute to the conversation, then and if it's proven that over time they're just undermining the conversation, if anything, not adding anything of value but taking away, then yeah, it's important to remove those people from the group, and I respect that decision. I think other people do too. We got some super chats coming in. People support this. We got a $9.99 from NeuroStream, and XS Fear gave us $10 on the super chats just now. So people support this, and then there's been a lot of that. They're saying that this is a great APEC is getting epic, and it's getting it needs to. We need to keep this as real as possible and eliminate the side conversation. Just cut to the real reality here. What do we need to do? How do we build it? How do we test it?
Oh yeah,
Test
that's
it. What do they find?
So did you say Jeremiah was working with spherical capacitors? Can you talk more about that?
I'm not Jeremiah. I can only say,
Jeremiah was on the stream last night talking a little bit about that on my channel, but he didn't really come out with it till later. And Daniel Foster is the guy that really knows about it. And
Well,
he's in the chat now. Actually, Daniel Foster he claims that he got an assassination attempt yesterday. Some guy tried to hit him with a truck and stuff over this, which is kind of crazy,
Well, what Jeremiah was getting at was in the WhatsApp group, there was this huge debate about what is a scalar, right? And I'm like, well, mathematically, like it's a dimensionless vector, and it's also like if you're using matrices, it's a 1 by X matrix, however many columns you have.
1 by 1, not 1 by X, 1 by 1.
Well, I mean, yeah, but if you're, it multiplies another matrix, but it's a one by one. You're right. But then Jeremiah, Maya, and both Mark were like, no, a scalar is a sphere. Like what Jeremiah said in private chat with me and Mark was that, if you can create a spherical capacitor, you charge the capacitor to, I don't know, 10 volts. And then on the outside of it, you're going to read a scaled amount. It's amplification is another, maybe it's not the correct word, but it amplifies the voltage that it's holding within a spherical capacitor.
It sounds like they were talking about, oh no, that wouldn't.
I mean, I only understand
Are they
scalar
talking
from
about like
mathematics.
where you have spherically symmetric capacitor plates, like 2 of them, or a single?
Yes, yeah. So it'd be like a nested shell, right? You'd have.
Okay, it sounds like they're talking about the topological Tesla coil device. That's different. That produces like scalar waves by some people's definition, but that's not the mathematical definition of scalar. What that's doing is it's producing an electrodynamic near field, and I use electrodynamic because you're not getting electromagnetic fields. All the electromagnetic fields cancel when you charge and discharge the thing, and the amplification is also an AC effect. In the DC regime, you're not going to see an electric field outside that capacitor because all the electric field is contained within. But the interesting thing about the electrodynamic field, it's essentially like a surface plasmon, and what you're doing with the topological Tesla coil is you've got your inductor between these 2 capacitor plates, and you've got a driving coil.
Our brain or left store.
But anyway, what was I saying? So yeah, you have essentially what you've made is a macroscopic analog of a quantum dot. So
we're neck deep in tech.
So what you've made is something you've made a plasmonic quantum dot, or a plasmonically resonating quantum dot, and the capacitors and the inductor define that property for that quantum dot. But it's not really a quantum dot because at optical frequencies, photons have slightly different properties than at radio frequencies. So if you wanted it to behave exactly like a quantum dot, you also need some of the materials you've built the structure out of to have an NMR resonance point at the point that the whole thing is operating at. And then on top of that, you probably want to drive it parametrically, and then you get into basically the Alcubierre-Froning drive potentially.
That's basically how to build a quantum computer, but doing
we're just talking about a single quantum dot. Single quantum bit.
Dots. So these are not qubits. These are like quantum dots. What's the difference?
Quantum dot is a nanoparticle which basically
surface, right? I've heard of like laser etching metal surfaces with a bunch of like dots, and they can make these quantum dots on the surface, and they create weird optical effects on the surface, right?
So you basically the quantum dots have some excitable state on the surface. So you get an exciton on the surface of this material, and that exciton.
Aiden, if you could mute while you're talking.
Yes, sir.
Jeremy, do you think I could make you the host? Would that work?
Yeah, sure. I'll take
Okay.
over.
Let me make you the host. I have to make dinner. It's getting to be dinner time for the crew here, so.
Word, I
Thanks,
just
Stu.
did some Chinese